Right, let's express these as single fractions then. Let's cross multiply this. 5d plus 3d, cross multiply, over the 3 5s of 15. So we get 8d, don't we, over 15. Here cross multiply again, 6q minus 4q over 4 2s are 8. So 6 minus 4 is 2q over 8. And there's a 2 common top and bottom, isn't there? So we can simplify that to q over 4. Here cross multiply 40k plus 2k over 2/8 is 16. 42k then over 16. There's a 4 common, isn't there? No, there's a 2 common. 8 and 21. 21k over 8. This one cross multiply b. A times 1 is a over the product underneath a, b, which it looks easier on the I if we write a plus b over ab. Okay, next one. Here, rather than cross multiply, I'm just going to scale this up to x squared, and then we can just add the fractions, because it's easier to do it by that method. Times by x top and bottom then, over x squared, and we get 3x plus 2 on the top. Same denominator, so we can add the fractions over x squared. Here we want the same fraction on the bottom, don't we? 4 over c cubed minus times by c top and bottom, so it's plus 3c over c cubed, times by c squared top and bottom then, minus 2c squared over c cubed, and times by c cubed top and bottom, and we can write 1 as c cubed over c cubed, with the minus of course. So we've all got the same denominator now, we've all tweaked it, written the equivalent fraction, with c cubed being the denominator, so we've got 4 plus 3c, so we can just combine them, can't we? Minus 2c squared minus c cubed, all over the fraction, the denominator, c cubed. Good. So let's move these down now. And we'll go at them. Right, this one cross multiply. I've put the bracket around them because we're moving the objects. Cross multiply 4x plus 2 plus 2 lots of the x plus 1 over the product underneath, x plus 1, x plus 2. So that's equal to then 4x plus 8 plus 2x plus 2 over the x plus 1, x plus 2, which I'll just leave as is. We could expand the bracket if we wanted. So what we've got, 6x plus 8 and 2 is 10 over x plus 1, x plus 2. And you could take out a 2 out as common, couldn't you? 2, so it would be 3x plus 5 over x plus 1, x plus 2. Okay, that's that one done. Last one then. Let's have a look at this one. So we need the same, I'll put the equals underneath because we're going to do a lot. We've got an x squared, but we've also got an x plus 1, so we need a denominator to be x squared x plus 1. So this needs to be scaled up by x plus 1. Because then, underneath, we've got x squared x plus 1, haven't we? I hope you can see that. This one, to get to x, we just times top and bottom by x plus 1. And that's the x squared x plus 1. And this one we times by x squared top and bottom. 3x squared over x squared x plus 1. So I hope you can see that. I'll just go through it just quickly. See, this will cancel, and the x's will cancel to leave 1 over x. This one, these will cancel, and we just got the 2 over x squareds. And this one, the x squareds will cancel, and we just have 3 over x plus 1. But now the denominators are the same, we can just put that underneath. x squared x plus 1. And since I'm just going to add this, this and this, I'm going to expand the bracket at the same time. X squared plus x plus 2x plus 2 and then plus 3x squared. So that equals then, how many x squareds have we got on top? 3, 4 x squareds. How many x's? 3x. And then plus 2 over x squared x plus 1. Now this might factorize on top. I'm not sure. It might do if it was a 4 and a 1. Just have a quick look. It wouldn't factorize if it was 2 and 2 because that would give an even product for the middle term because it's 2 and 2. And that's a 3, it's odd. It has to have a 1, an odd term here. 2 1s, I don't know if it does. No, because it's a plus. I don't think it factorizes, so I think that's actually the final answer there.